I'm going to go ahead and get started then. So it says section 2.1. This is just for the chapter because Pearson has everything labeled as like through the chapters, but we condensed it down into 6 different modules. So just ignore where it says section 2.1. So this is over the module for set theory. And set theory is just all about placing things into categories. Some examples of that would be like your gender, your age, whenever you're filling out applications, if they're looking for a particular applicant, they can use certain characteristics like that to narrow down your applications. So there are some definitions that you will need to know. We have 6 different definitions. We have the definition of a set, which is just a collection of objects whose contents can be clearly determined. Each set has elements or members. We call them elements, and those are just all of the objects that are in a set. Some of the questions will ask you to list out the elements using roster method. Whenever you use roster method, we're just basically listing all of the elements inside a pair of braces, and we're separating the elements with commas. So if you look down below at the notations and formulas, it has a little example for you for roster method. The next definition is empty set, which is a set that contains no elements. And then as Dr. Gosman was talking about with the natural numbers, your natural numbers are your counting numbers, and he gave y'all some examples and some more information about those. And then the last definition is your cardinal number or cardinality, which is just the number of elements in a set. So these are the main things that we will go over in this first section. This is lesson 1 in module 1. So if you're in Canvas and you click on module 1, it is broken up into 4 different lessons. Lesson 1, 2, 3, and 4. So lesson 1 is what we're focusing on today. And the homework can be found at the end of these. So you can either get to the homework going through here, and then you'd have to go to the next page, and you can find the homework here. Or you can actually click on My Lab and Mastering, and it'll take you to all of the assignments, not just this one. So I'm just going to go over some exercises that you need to know for this particular section. And if anybody has any questions, just stop me while I'm talking and we can discuss it. So set builder notation, this is what Pearson is going to give you the examples or the exercises as. And the way that this reads is that we have the set W is the set of all elements X such that X is a day of the week. So the main thing that you need to worry about, where's my highlighter? Oh, here it is. The main thing that we will be looking at is this part right here. X is the day of the week. So there are going to be different conditions in all of these different exercises. And then these notations down here are just notations of the stuff that we were talking about. So the empty set can be represented with the braces with nothing in it, or you can use this 0 with the line drawn through it, which is the null symbol. Yes. Some other symbols that we'll look at, we have this E, which means an object is an element of a set. And then the E with the line drawn through it is the object is not an element of the set. Yes. It's set W is the set of all elements X such that, and then your information. X is a day of the week. I know it's a little confusing right now whenever you first see it. But let's go ahead and look at the first exercise. So we talked about the natural numbers. Those are your counting numbers. So whenever you see this right here, that means that X is a natural number. So that means that we are only looking at the counting numbers. So no negative numbers. Yes. Yes. So like I said up there, this part at the end is going to be your condition. These are the main points that we need to know for these problems. On number 1, letter A, it says the set. So it says express the set using the roster method. So the roster method, we need our braces and we need to separate all of the elements with a comma. So this first one, letter A, is just written out. It says we're looking at the set of odd natural numbers less than 13. So since we're looking at the natural numbers, we know that we're looking at our positive numbers. We are also looking at the odd numbers and then less than 13. So what would y'all think is in this set? Yes, 1, 3, 5, 7, 9, and 11. And I have opened it up with braces at the end, at the beginning, and then closed it at the end, and then put a comma between all the elements. All right. On B, it says that we are still looking at our natural numbers, and we have that X is less than or equal to 5. Does everybody remember what less than or equal to, greater than, and then greater than or equal to mean? So anytime if we have less than or greater than, we are not including that number. Whenever we have less than or equal to or greater than or equal to, we do include that number. So in this case, we have that X is less than or equal to 5. Yes. Yep. So we got 1, 2, 3, 4, and 5. All right, on C, we have that X is between 6 and 10. So another way that I suggest to write this is to break it up into 2 different inequalities. So we have 6 less than X, and then X is less than or equal to 10. And we can actually turn this one around. So our alligator mouth is open to the X, so we are going to keep it open to the X. So we have that X is greater than 6 and that X is less than or equal to 10. So if it's greater than 6, are we going to include 6? No. So we are starting with the number 7. Are we including 10? Yes. So we've got 7, 8, 9, and 10. Is everybody okay with that? On D, we have that X plus 5 equals 7. So what number would we put for this one? 2. And then on E, we have that X is between 15 and 60. So I'm just going to split it up again. Whatever way the alligator mouth is open, we're going to leave it open to the X. So X is greater than or equal to 15, and X is less than 60. So what numbers would be in this set? $15, $16, $17, all the way to what? $59, yes. Yes, so you can use 3 dots, and that just means that it continues. And I think most of these on your homework are multiple choice, so you don't have to actually list all these out. All right, number 2, it says determine if this set is the empty set. So we talked about the set being empty. If there are no elements, then that means it is the empty set. So we have our conditions. I'm going to highlight these again. These are the main parts that we are looking at. On A, it says that X is less than 2 and X is greater than 5. So I'm actually going to draw a number line so we can look at this. So X is less than 2. So I'm going to do 0, 1, 2, 3, 4, 5, 6, and 7. So if X is less than 2, we are not including 2, but we're doing everything that is less than. So it would be 1, 0, and everything down. And if X is greater than 5, we're going to do everything to the right of 5. So is it possible for a number to be less than 2 and greater than 5? No. So that means that this is the empty set. Is everybody okay with that? All right. On B, we have that X is less than 3 and X is greater than 7. So kind of the same concept. We have X is less than 3 and X is greater than 7. So this is also empty. Does everybody see? Yes. Yes. So if they ask you to, I think on this particular question, it's going to be multiple choice, and you have to say, like, the set is empty because there's not a number that's less than and greater than. I think that's how the questions are set up. On C, we have that X is a natural number, so we're looking at our counting numbers, and we have that X is between 2 and 5. So if I put this on the number line, 0, 1, 2, 3, 4, 5, 6. Yep, 3 and 4. So is this set empty or not empty? We have 2 elements. We have 3 and 4. So this set would not be empty. No, I think it's going to be multiple choice. They're just asking you if the set is empty or not empty. And then the last one is similar. We have X between 3 and 7. So is this set empty or not empty? Not empty. Is everybody okay on those? Alrighty. Number 3, determine whether each statement is true or false. So remember, anytime you see this element, this symbol, it means that an object is an element of. And when you see this with the line through it, it means is not an element. So on A, it says that 3 is an element of the set of numbers 1, 3, 5, and 7. Is this true or false? This is true because 3 is an element. Okay. What about on B? 5 is an element of the set of numbers. It looks like they're even numbers 2, 4, 6, all the way to 20. False, because 5 is not an element. Okay. What about C? It says 11 is not an element of the set of numbers 1, 2, 3, all the way to number 9. Correct. It is true. Because 11 is not an element of this set. And then on D, 37 is not an element of the numbers 1, 2, 3, all the way to 40. False, because 37 is in there. All right. And then this last exercise is find the cardinal number for each set. So cardinal number is going to be the number of elements. Can y'all see this color okay? Number of elements in the set. So anytime that you represent the cardinal number, they use this N with parentheses. And they put the name of the set inside the parentheses. So you're going to have some questions where they have this, and that means that they're looking for the cardinal number. So I'm going to write out these answers using this notation right here. So it says that on letter A, S equals the set of numbers 2, 4, 6, all the way to 30. So what would our cardinal number be? It is 15 because we're only looking at the even numbers. So I'm going to use the little n and then parentheses, and the S is in the parentheses because that's the name of our set. And the cardinal number of this set S equals 15. Yes, correct. All right, on B, it says we have our set W, and the main thing that we're looking at is this condition right here, which says that X is a letter in the word 5. So if we were to list out this set using roster method, it would look like this. It would be just the letters F, I, V, and E. So what would our cardinal number be? 4, yes. So Pearson, they like to do stuff like this where they try to trick you because they have the word 5, but your cardinal number is actually 4. All right, and then our last one is we are looking at the set G, and we are looking at this condition where X is between 2 and 7. Can somebody tell me what numbers are in our set? Yes. Okay, so what would our cardinal number of G be? 5, yes. Is everybody okay with that? Okay. B? Okay, so it's our condition at the end says that X is a letter in the word five. So we're looking at this word five. So if we are to list out that word using the roster method, it would look like this because we have the letters F, I, V, and E. So we're not looking at this particular word, we're looking at the letters. So each letter is its own element. Yes.